Hi, this is Osama Al-Amrani. I am a grade 9 student at Al-Nada Modern School in Sana'a, Yemen. Today I will talk about acids and bases. Ever wondered why lemon tastes sour and soap feels slippery? It's all about the fascinating world of acids and bases. Let's embark on a journey into this intriguing world, a world that's closer to your everyday life than you might think. Picture this. You're biting into a juicy lemon. That sour taste? That's citric acid at work. Or imagine you're washing your hands with soap. That slippery feeling. You can thank bases for that. Acids and bases are not just scientific terms confined to the walls of a laboratory. They're integral parts of our daily lives, present in the food we eat, the beverages we drink, and the products we use. They're in the fizzy soda that quenches your thirst on a hot summer day, the vinegar that adds a tangy kick to your salad, and even in the batteries that power your remote controls. But before we delve deeper, let's understand what these terms mean. At its simplest, an acid is a substance that donates hydrogen ions, while a base is a substance that accepts them. This exchange of hydrogen ions is behind the reactions that acids and bases undergo. However, it's not all about science. Acids and bases also play a crucial role in our health and well-being. For instance, our stomach uses hydrochloric acid to break down food, while our blood maintains a slightly basic pH to keep us healthy. Moreover, they're key players in many industrial processes. From the production of soap and detergents to the manufacture of fertilizers and plastics, acids and bases are indispensable. But remember, while they're extremely useful, they can also be harmful if not handled properly. Acids can be corrosive and cause burns, while some bases are caustic and can damage tissues. So it's important to handle them with care. Intrigued? We're only scratching the surface. There's so much more to learn about these fascinating substances and their impact on our lives. So, acids and bases are not just limited to your chemistry lab, they're everywhere. Now let's delve deeper and explore what makes acids sour and bases slippery. Step into the world of chemistry and you'll discover that acids and bases are not just scientific terms, but have distinct properties that make them unique. Acids, for instance, are often associated with a sour taste. Ever bit into a lemon and cringed at the tartness? That's citric acid at work. But there's more to acids than just their sour taste. They are also corrosive, which means they have the ability to wear down or destroy substances. This corrosive nature is why certain acids are used in industries to clean metal surfaces or etch patterns onto glass. One of the easiest ways to identify an acid is by using a blue litmus paper. When dipped into an acidic solution, the paper turns red, a reaction that never fails to amaze. It's like having your own little magic trick in the lab. Now, let's talk about bases. Unlike the sour taste of acids, bases tend to have a bitter taste. Think of the slight bitterness of baking soda, which is a common base used in cooking. The most noticeable physical property of bases, however, is their slippery texture. This is why many cleaning products contain bases. They help to slip the dirt off surfaces. But remember, just like acids, certain bases can be corrosive too, so handle with care. Much like their acidic counterparts, bases have their own litmus paper test. A red litmus paper turns blue when it comes into contact with a basic solution. It's another fascinating chemical reaction that adds a dash of color to science. Interesting, isn't it? How these properties help us identify whether a substance is an acid or a base. The world of acids and bases is filled with intriguing reactions and properties, making chemistry not just a subject of study, but a journey of discovery. So buckle up, and let's continue to explore this captivating world together. Scene script. Wondering how these acids and bases react? Let's find out. When acids and bases meet, they don't always get along, and that's where the fun begins. Picture this, an acid strolling along, minding its own business, when suddenly it bumps into a base. What happens next? A lively tango called neutralization. Neutralization is the process where an acid and a base react to form water and a salt. It's like a peace treaty between two opposing forces, resulting in a neutral solution. The acid donates a proton, and the base graciously accepts it, leading to the formation of water. Simultaneously, the acid's anion and the base's cation come together in a beautiful union, creating a salt. Take, for instance, the reaction between hydrochloric acid and sodium hydroxide. These two, when they meet, form water and sodium chloride, which is your everyday table salt. Quite the party trick, wouldn't you say? But let's not forget, not all reactions are this cordial. Some acids and bases just can't help but show off their strength. Strong acids, like sulfuric acid, and strong bases, like potassium hydroxide, don't just stop at donating and accepting one proton. They go all out, donating or accepting 2 protons, leading to the formation of water and a double salt. Talk about overachievers. And then there are the weak acids and bases. They take things slow, partially dissociating into their ions. Acetic acid, for example, doesn't fully ionize in water, making it a weak acid. But no matter how strong or weak, how cordial or dramatic, the reaction between acids and bases is a dance of particles, a spectacle of chemistry at its finest. It's all about balance, about give and take, about the creation of something new from the interaction of opposites. And that's how the magic of chemistry unfolds when acids and bases interact. Fascinating, isn't it? Now that we've seen the reactions, let's identify some common acids and bases around us. First up in our list of familiar acids is hydrochloric acid. You might think this sounds like something from a high-tech laboratory, but it's actually a major component of our stomach acid. It helps us digest food by breaking down proteins, a crucial step in our digestive process. Next, we have sulfuric acid. This might sound dangerous, and in its concentrated form, it is. But did you know that it's also a key ingredient in car batteries? It's what enables the battery to store energy and then release it to start your car. Another everyday acid is acetic acid. It doesn't just have a fancy name, it's the acid that gives vinegar its distinctive sour taste. So, every time you're enjoying a salad dressing or pickles, you're experiencing the tangy touch of acetic acid. Moving on to bases, let's start with sodium hydroxide. This is often found in household cleaning products. It's what gives these products their grease-cutting power, making your kitchen surfaces shine. Another common base is ammonium hydroxide. This might not sound familiar, but it's commonly used in household cleaning products just like sodium hydroxide. It's also used in the production of fertilizers, so it plays a vital role in helping our plants grow. So, as you can see, acids and bases are not just abstract concepts confined to the laboratory. They are real, tangible substances that we interact with in our daily lives. From our digestive process to car batteries, salad dressings to cleaning products and fertilizers, these chemical heroes are working tirelessly behind the scenes. And remember, understanding these substances is not just about knowing their names or formulas. It's about appreciating their roles, their functions, and their impact on our lives. So next time you see these substances, you know whether they're an acid or a base. Ever heard of acid rain? Let's understand how our acids and bases play a role in the environment. First off, acid rain isn't your typical downpour. It's a form of precipitation with high levels of nitric and sulfuric acids. Now you might wonder, where do these acids come from? Well, they're created by certain pollutants released in the air. When we burn fossil fuels such as coal and oil, they discharge sulfur dioxide and nitrogen oxides. These gases interact with water, oxygen, and other substances in the atmosphere to form sulfuric and nitric acids, which then fall to the ground as acid rain. The impact of acid rain on the environment is profound. It acidifies bodies of water such as lakes and streams, making the environment unsuitable for many types of fish and other aquatic life. It can also damage forests, particularly high-altitude ones where the cloud cover is more acidic than rainfall. Acid rain even has the ability to erode buildings and monuments, especially those made of limestone and marble, which contain large amounts of calcium carbonate, a substance easily dissolved by acid. Now let's bring bases into the picture. While we don't have something called base rain, bases still play a significant role in the environment. Certain bases, like calcium hydroxide, are often used to neutralize the effects of acid rain in lakes, rivers, and soils. This process is known as liming, and it helps restore the pH balance of affected areas. But remember, it's not all about combating acid with base. The key here is balance. Balancing chemical reactions is crucial to maintaining a healthy environment. Too much acid or base can disrupt ecosystems and harm biodiversity. It's a delicate scale that we must respect. So acids and bases not only impact our lives, but also the environment around us. It's our responsibility to understand and manage them well.